So this was a 1, right?
Yeah.
Forget about this part. So what I'm saying is, let's consider the first example, okay? So what I'm saying is the following, right? So in this case, you start from here, the first bit, right?
Yeah.
Okay. And so you see a 1. So now you increment your pointer to here at this location, okay? So, and then you see a 1. So you basically, so initial, let's say flag is false, okay? And when you see a 1, you basically set a flag as false, which is already false, by the way.
Yeah.
And now you increment the pointer by 2, right? So it reaches to 0. And now if you see 0, you will set the flag as true. And now after that, I will increment the 1. And so my loop ends and I return the flag.
Return the flag, yeah.
Wait, so it's counting the ones, and when they are odd, then it's false, correct?
Yes, that is true. So look at line number 6 in the code. So if it's 1, you basically increment the counter by 2 and set the flag as false. Otherwise, increment the counter by 1 and set the flag as true and return the flag. And initial flag is false, because if the array is empty, you cannot do it. Yeah, one other optimization is even if before even jumping this guy, just check the last bit. If it's 1, it cannot be the answer. Yeah.
Okay.
But yeah.
Because the way it's explained, it's a little bit confusing. I don't know.
Oh, is it?
No. The
problem statement.
The problem is statement itself. Yeah.
Right.
I see.
So the way he is doing it, whenever he hits on a 1, he counts, increments the index by 2. And the reason why he's doing, because the 2-bit character always starts with 1. Right. And that is the only 1-bit character which starts with 0. So whenever you hit onto a 0, it is an 1-bit character. Yeah. And
okay.
It's very good way of doing it. Yeah.
Got it.
Yeah.
Thanks, man.
Thanks, Gaurav. Yeah. Any questions before we move on to the next one? Okay, Shashank, you can take over.
You want to continue? I can continue if you want.
Yeah, you continue. Yeah, sure.
Okay.
Do you want me to make you host?
No, it's okay. Just I will share it.
Yeah,
that's
sure.
it. Yeah. Okay. Yeah, we'll start with the second one. Sorry for the delay. Like network was not working.
No, it's okay. Yeah.
Okay. So it's statistics from a large sample. We are sampled integers are given, that is array of size 256, and we are storing the results in array count. Count of k is the number of integers we sampled equal to the k. We need to return the minimum, maximum, mean, median, mode of the sample respectively as an array of floating point numbers, and the mode is guaranteed to be unique in this case. And they have given the definition of median as if the median is the middle element if your array is sorted and the number of elements in them is odd. Else you have to take the average of the middle two elements if the array number of elements is even. So it's like this is a count array. What it says, like 0 stands for no data, and 1 frequent, like index 1 is occurring once, index 2 is occurring 3 times, and index 3 is occurring 4 times, and remaining index 5 0 0 0, all these are 0 0 0. And now we have to find minimum. So minimum for them is 1, and max is your minimum, maximum is 3. That's the index they are giving, because see, if 1 is if you start from the left side, the minimum element you will get over is 1, which is of index 1. So they have taken the float of the index, so they have given as 1. And maximum, if you start maximum you will reach here is 4, and 4 stands at index 3, and float of that is this. And minimum,
so like these values of minimum and maximum,
yeah,
they are just a starting index of non-zero values.
Yeah, exactly.
That will be maximum will be the ending index of a non-zero value.
Non-zero value,
Yeah.
yeah. If
So
you
if
go
we
from
have like,
behind, okay. Yeah. I mean, same thing. Like what if you go from back, whatever first non-zero element you get, because it's a sorted, so that will give you the max and take the index and convert to float. Yeah. Say, continue.
yeah. So based on the problem statement, if you just read the problem statement and this example is not given, then it's not very clear, right? Because I didn't
Yeah,
understand
is
that.
in
Yeah, I didn't understand it either.
Right.
Yeah.
uh, problem is they again count of k is the number of integers we sampled equal to k. I couldn't understand. I saw this solution section, and then from there I got the uh, derived meaning out of it.
Yeah,
Because
if
they are
you
not.
if you see the second example, that actually make it clear that
But
the max is if somebody get confused with the value at that index. So here in the second example, value is still small, and that is the max.
So
yeah.
so the first one should be the mean value, right? So this
Yeah,
in case
that's what I understood too. Yeah.
No, you have to sort it. Whatever values are having, you sort it. So 2 will come first, and 3, and then 4. And among them, either you can take, so index 1 is 2 and index 2 is 2. So whichever you take, that will be minimum because both are equal here.
Oh, you have to sort it.
Why does it start with 0 always?
I don't think you have to
No,
sort it, right? Yeah.
0 indicates that zeroth index is occurring 0 number of times. These are the frequency of the indexes, how many times they are occurring.
So when you sort it,
Sort it, then you'll get 2 because these are no data. All the zeros are null. So remove them from the array.
So when you
Now
sort it,
when
is it gonna be 0, 2, 2, 3, 4, or is it gonna be 2, 2, 3, 4?
No,
0, 2, 2, 3, 4.
So this array is so if you see the problem statement, it says that the index is actually the number, and the value at that index is the frequency of that number in the set.
Yeah, I understand that.
Yeah. So the minimum will be the first smallest element in the set.
I see. It will be the minimum will be the first index, which is 0, right?
Which is non-zero.
Non-zero element, because zero means that is not available
okay,
in the set.
Yeah, that is true. That is true.
Yeah.
Oh, I see. Okay.
And the same way, the maximum is the largest index which is in the available in the set or present in the set.
I see.
But it's not explicitly clear, I think, in the question somewhere.
Yeah.
From
so
which
also like you have like 1, 3, 4 as in the first example, then you have many zeros, and then if you have some number on a 200 number somewhere,
yeah,
example, so that will be the high maximum one, right?
Yes, that will be the maximum one.
Okay.
No, the minimum and maximum in terms of value or in terms of frequency?
In terms of index.
Index only, yeah.
So the index which has some value greater than 0.
So if we have, let's say, at 200 position, we have number 2. So that will be the maximum 2.
Yeah, the max will be
index
2.
corresponding to that number.
Right.
Yep.
And what is the mode in this case then?
Mode is basically the highest frequency number, right?
Highest frequency number. Yeah. So
yeah, and how you guys computed the median?
Median for computing that, you check it like you sum them up, all the frequency. Okay. So 43718, it's even, and they have given the definition like if your average of the median, if it's even, then you take middle of the two. Like here, 8 will be there, right? Entire sum. It's an even. 8 divided by 2, 4. And you got 4. So 4 will lie in the range 1 to 3, and fifth element will start from 4, right? You are getting like 4 elements have already consumed here. So fifth element, index 3 will be repeated 4 times. So fifth will start from here. So you have to take average of those two.
So you have to take average of 3 and 4 in this case.
Means
the index 2 and 3.
2 plus 3 by 2, yeah, 2.5. This is 2.5.
Yeah, and then you have to give the sample number, right? Okay. So that is what you need to divide. Okay.
So for median, right? Median is basically the middle element, right? In case of odds, otherwise in case of even, it's a divide by 2. Am I right?
Yeah, middle
Yes.
two element divided
Yes.
by
So
2.
in this case, so if you look at it 1, 3, and 4, it will be like 1, and then 2, 2, 2, and then 3, 3, 3, 3. Right? That's actually
4
the
times 7.
original numbers, right? So you have to find the
Okay.
middle element out of these. So you are saying you did the sum and then divide by 2 and or odd or even based on that, right?
Yeah.
Right. And then and how you figure out, did you do a binary search or something in this case?
Binary search, no, I didn't do binary search. Normal, like I just wrote this function, calculated the yes.
I think we can just actually get the count for all the numbers, and then in the second loop we can find that based on that the count, we can find the middle.
So if let's say one of the number is 1 million times, so what will be your complexity? And there is only 3 elements. So what will be your complexity? O of 3 or O of million?
But we are
No.
just taking the indexes, right, in this case.
Yeah, but for median, you cannot rely only on indexes. You have to rely on the frequencies, right?
No, but you have,
can you
yeah,
have
you have the, no,
calculated the total number of,
number is between 0 to 255, right?
Yeah, that's indexes, right?
so suppose if you have calculated the total number of elements present, the total frequency, if you add all the frequencies.
you
So
just add all the frequencies.
Median would start occurring when you have crossed it. You are around halfway mark. So again, in next iteration, you are adding. So whenever you are near the halfway mark, you'll know your median is about to. So based on the index that is crossing, you can figure out whether the median would be the sum of or just the exact element, depending on the odd number.
Oh, I see. So
You're
it will
just,
still be O of n. Okay.
Yeah,
Like
you
yes.
just
O of
iterate on.
255. Okay.
so you are saying like add all the counts first, and then divide by 2. When you add the count, you know if it is even or odd. So if it is even, you know that you have to actually add 2 samples.
Yes.
So then you find the middle element, and then you get that sample number, and then you add that with the next one and divide by 2. That will be your median. And if it is odd, just you have to go to that sample and return that value. Am I right? I think.
Yeah, it's a similar approach, I think. But they have not mentioned anything like so explicitly, right?
It's
like,
very hard if someone just gives without the examples to actually implement that in an interview. Is going to be very difficult. It looks
I
very
thought
easy.
I thought I was the only one. So yesterday I was before.
Yeah, actually, they should have, because these are the
What happened
mathematical
to me?
terms, so they did, that's why they did not mention here.
Could we
But,
walk through the second example?
yeah, sure. So yeah, the number is given 4322. Okay, so first non-zero number, what we are getting from left, 4, right? So for, corresponding to that, we have taken index as 1. And for the maximum, what you'll get from behind, if you go backside, this is the first time you're occurring non-zero element. So I've taken max as 4, and this is, what is that, max mean, regarding the mean. Mean, how will you do? You take the number multiplied by index 3, so 0 1, 4 multiplied by 1, 3 multiplied by 2, 2 multiplied by 3, and this 2 multiplied by 4. Club them up and then divide it by 4 3 7 and 7 4 11. Divide by 11, you'll get this as a mean. And mode is 1 here because this is the highest frequency. So you don't need to sort it here, sorry. Corresponding to this 4, you'll get the index. So 1 is the mode, and this is again median. So when you club them 2 2 4 3 7 11, it becomes odd, right? So if you have odd, you can take the odd 7 by 2. 7 by 2 will be 3. So corresponding to 3, I think the index will be 2. So they have taken as 2.
No, I think that when they said, as far as I mean, I read up. If you see the problem in the beginning, it says if the elements in the sample was sorted and the number of elements is odd, take the middle one. So I think the middle one is 2. No, if we go down.
Middle one will be no. You have
Oh,
to sum them
it's
up. How will you come to know that whether it is odd or even?
oh, you mean that when they summed up, not the number of elements? Because I think
Yeah,
here
yeah,
it
yeah.
mentioned number of elements.
No, frequency. You
Yeah,
have
so
to.
number of element in this example will be 11.
11 is odd.
Yeah, so 11 divided by 2 will be 5. So the fifth element will lie in the index 2 because you have already have 4
Yeah.
in the first one. So therefore you are retaining the second
Four.
index.
Yeah.
Yeah.
Okay. Okay.
I think Sasank, if you can actually expand that and show that,
Whiteboard.
yeah,
Sure.
yeah, that will be easy to visualize that.
Yeah. So like that means 1 is occurring 4 times. 1, 2, 3, 4. Okay. 3 is occurring. Sorry, 2 is occurring 3 times. 3 and 0, 1, 2, 3 is occurring 2 times. And 0, 1, 2, 3 is occurring again 2 times. Sorry, 4. 4 is occurring 2 times. So when you let's say number is given like this, if you sum them, we are summing the frequency of these numbers. So if you 2 to 4, it will be entirely will be 11. Now 11 by 2, because since it's odd number of elements are present here. 11 by 2 will be 5. So 1, 2, 3, 4. So first array got covered. Four elements you have, and 5 will come in the section of these 3 2s. So index of these 3 2 is 2. Index of these 3 is 2. So we are returning 2 for that. And anyways, that will be middle. You see, if this is the middle element, this 2. Left to this is 5 and right to this is 5. Or any confusion in this? I think am I audible, right?
Yep.
Yeah, it's clear now.
Yeah, so I mean, if you have 5 elements you have to take from the left. So first 4 will be washed out in the index 1, and next first element, this will be 4, and when you go to this will be 5 from the left. So it and these two, all these 3 2 will fall in the index number 2. So the output corresponding to that is 2. And regarding the mode, 1 is occurring, you can see maximum. Mode is defined as the maximum number of times element is occurring. So this is 4. So index corresponding to these elements are 1. So this mode is this, and this is like mean. For mean, you can take 4 into 1 plus 3 into 2, and then 2 into 3 plus 2 into 4. So this, I think,
24, right?
12. Pardon?
24.
24.
Yeah.
No, is 8.
And 24 divided by 11. Yeah.
11. I think it will be same only.
Yeah.
Yeah, it will be, I think, same. Let's check it.
Yeah.
What it is.
0.3.
Oh, it's coming 0.3.
Yeah.
Oh, yeah. 0.3 it is coming.
Yeah.
24 divided by 11.
0.36.
It is 2.181818. Yeah, that's correct. So if you
Yeah,
divide
that's
24
correct.
by 11, it is going to be 2.1818181818.
Somebody was saying 0.3.
No, no.
Okay, okay. Yeah, that makes sense.
Because 11 divided by 24, at least going to come 2, right?
Yeah, 11 to the 22. 2 will
22, yeah.
definitely come.
And 2 by 11,
Mhm.
so it is going to be 1818.
One-
Yeah, that's correct answer.
Yeah. So any queries in this, we'll go for the implementation. Implementation is we discussed only like for minimum for the first element whom you counter as non-zero, return take the index and convert it to float. For maximum, I'm reversing it from the backside, and whenever you encounter the first non-zero element, that will give you the maximum. Regarding mode will give you, this is index is used for picking the index, and maximum of the counts value you got as here for this is one, and we'll pick the index of it and convert it to float. Mean, again, index multiplying with the frequency to dividing it by the total value. And regarding median, I have taken one helper function, first summing up all the frequencies. Now we'll check that index should be less than equal to the sum counts whatever we have done till now. Otherwise, if it goes beyond that, then there is no, I mean, we need to return that the index corresponding to that only. Like let's say if we get some value which is greater than this 4, so we'll return that particular index from yeah, that particular k will return. And just for even, for odd, dividing by 2, and for even, median index minus 1, and we are calling it for the first index and second index and returning the float value of it. Any queries in the implementation?
Yeah, I'm confused with the median. Can you?
Yeah, sure. You first you take the index and its count, okay? Uh, this is the helper function. Let's start from here. First, we'll sum total all the elements in the counts. All the non-zero elements, will club them up. You divide by 2. Just check whether it's an even or odd. If it is 1, that means it's odd. So you just divide by 2 and pass it through the helper function, that index. That particular you will pass it over there. After that, corresponding you will pick the index and its frequency and check if the frequency is greater than 0. That means it shouldn't be zero element. The frequency should not be 0. The frequency should be something greater than 0. We are summing them up, and this is the cross check to see the index that you have returned from here, that should be less than your sum counts, whatever sum total you have done for that. If it is less than this, then we don't need to return the other part. You just return the k, that index, you return it.
Yeah, so like in the example of 4, 1 and 2, so
Yeah.
we got the 5 and you sent the value index is 5. And
Yeah.
so k, okay, self dot counts, so k and count k will be what? 0, and then count will be 1.
Index.
Yeah, and then okay.
Okay.
Then
Since count,
yeah, then what happens next? Like
you will sum total all those counts.
oh yeah, so that time it is
Yeah.
4. So 1, so index 1 and count is 4.
4, yeah.
Okay, and then you are checking that if you have reached to that value index.
Yeah. That is this one to confirm, like this 5 was here, so 4 elements was consumed over here. If you are within this index, within the index of 3, if you are able, if 5 gets finished within this 3 2, what do you say? Then you'll return the index of these 3 2. Yeah.
Yeah.
Let's say if you had the element been 7, then you'll reach in this portion, 3 3 portion, because 4 3 and I think still 7 8. If you get, let's say if you get 8, had you got 8, then 4 here and 3 here, 4 3 7, then 8 will come in this 3 3, and index of this you'll have to return. That is what I'm checking, if the value index is less than the sum count.
Yeah, got it.
Yeah. Oh.
Yeah, so you're calling the same helper function 2 times with 2 different indexes. Okay.
Yeah,
For the
exactly.
even. Yeah, okay, fine.
Okay. And this, we are calling all the functions here and returning the array. Anybody wants to share anything? I mean, any other code like?
I think so. This is good.
Pardon?
This is good. Yeah.
Okay. Okay, then shall we proceed to next, right?
Yeah.
Okay. Yeah. The word break problem. It's a sequel of, I think, previous problem. Given a non-empty string S and a dictionary word date containing a list of empty words, add spaces in S to construct a sentence where each word is a valid dictionary word and return all such possible sentences. The same word in the dictionary may be reused multiple times in the segmentation, and you may assume the dictionary doesn't contain any duplicate words. So let's say the entire string is given a cat, sand, dog, and these are the words, and we have to generate the outputs like cat is present here. If you put a space after cat, you'll get sand, and sand is again present, so that's again a valid one. Cat, sand, and after that dog. For a first example, we are putting a space after cats and then dog. Same way here. First is for pine, space apple, pen, apple, or pineapple. You can get, that's also a fine word, pineapple, and then space, pen, and then apple, and so on. Note that you are not allowed to reuse a dictionary word. But here, if we see cats, you can get, okay. Cats you can get, but an is not any word. If you try to put any space after cat, an will be there, which is useless. Had there been 2 days, we could have used this. So we have to return here empty array. And if you take after cat, but cat is a valid word. And if you use sand, but sand is there, but dog you won't be able to get here. D is not there, so returning the empty list. OG will be left in the string. I think none of them should be left. String shouldn't be left empty. I mean, remaining character should not be there in the string after once you pass through the entire string. Like here, OG will be left, and OG doesn't make any sense. So we're returning. So any queries in that query?
We need to use
Pardon?
each and every alphabet and just
yeah,
put some spaces in that to make a complete statement, or else we don't return it, right? Yeah.
Anything. Yeah. Yeah,
Is
any
there a way?
approach?
Is there a way we
Yes.
can draw this problem as a, as a tree or something? You think?
I thought first
Just to
of a
visualize it.
graph, like I think
Maybe like a try.
Say.
Maybe like a try, a tree, but it like look like a try.
Yeah, even
try,
I think
Yeah.
even I think it can be solved with a try and the DFS.
DFS also we can use. Backtracking we can use here.
Yeah, I think try and DFS will be helpful here.
Yeah, try I'm not aware of much, but I think so. How does try work? Like, can you give some?
But try is just for storage, right? So you will just store the word dictionary in a try, right?
Okay.
So either you store this word dictionary in some sort of a hash table, or maybe a try, then use it. Correct. This is what I'm, coming from the discussion what you guys are having.
Yeah, that is true. It just the try will give you much better efficiency.
Yeah, that is true. Yeah. But you will have to still construct the try.
Yeah, that is true.
Okay.
What would be the brute force in this one approach?
Brute force, like generate all the substrings of this and match with, if it matches with any of the word, then take it. I mean, generate all the possible substring out of this string. Okay. After that, take every substring and match it. If it occurs in the dictionary, put in the output section, and then go ahead again, check it. I think,
Yeah.
or any
What
other.
What about like, create a hash map, like a map where the key is the number of character, and the value would be a list of word that have the same size.
No, but orientation of letters will matter. No, like cats and has same number of letters, right?
Mm.
Cat has 3 and has 3, but the orientation of letters matter here, and which letter you are using, that also matters.
Yeah.
Yeah, so I think that might create a trouble.
Yeah, I think what he's suggesting that based on the substring, so based on the length, create a hash map, and then the
Probably you will
and the
set.
value will be the list, and then for each string, then either you can have a hash set or a list for substring. So when you actually
So
you
yeah,
actually get the substring for that particular length, so you just need to check in that.
So let's say you will put cat as a key in the hash map, right?
no, the key is 3 because it's 3 characters.
The length 3.
Yeah.
Okay, key
And
3.
the value will be a set.
Yeah, so what he's suggesting
So
that
cat
so
and
there
and
will go ahead, please.
go
Can
ahead,
we
yeah.
draw it here, so I think that would be
Good.
much clearer. Shashank,
Yeah, sure.
just say like 3 and then, yeah.
Corresponding to 3, yeah.
Yeah, so
You're telling.
whatever the verdicts are, like
The 3, then cat and a dog.
Can I show you
Okay.
something real quick?
Sure. Let me stop my share.
Yeah.
Go ahead.
Yeah, do you see my notes?
Yeah.
So I was thinking about drawing something like this. Do you think this is going to be helpful? So we start with the string, the whole string, and then we divide it first with cat or cats, and then the rest of the string.
Oh.
And then we divide this, the remaining of it.
How do you know when to insert the space?
We check
From the list
for
of the
dictionary.
Yeah. I think Leon, he is actually going the brute force way, and actually we will come after this discussion. First, let's go with this now first.
Okay.
Yeah. Okay. Go ahead, Martin.
No. So I was asking, is this a valid way to kind of visualize how we need to actually solve the problem? So first we have the input, which is the whole string cats and dog. And then we divide, first of all, we have one word in the dictionary, which is cat, and then we have another word in the dictionary, which is cats. So we divide both. We kind of can go both ways. And then if we go with cat and send dog, then we have only one option, which is send dog. And then for cats and dog, for end dog, we have and dog. Correct?
Yep.
Yeah.
How we can, okay. I just want to see
so
if
this, like, if you think of implementing this, it's like a DFS.
yes.
Okay.
Yeah, it should be DFS, correct?
Oh, it kind of look like a suffix problem.
Prefix.
Because we saw the prefix already, and the suffix is unknown. Right? You break it.
So you're saying prefix tree?
I mean, cat is a prefix only for the word cats and dog, right?
Okay.
And then you actually use a recursive function, and then if it is going to TLE, then do a memorize version, like a top-down approach, right?
Yeah.
Okay. Yeah, that should work. Yeah. So you actually iterate through the whole string first, taking a length value as 1. So you'll just see C, and then there is no word in dictionary which is C.
Yeah,
then
so until we find
2.
a word, and then we go down the tree.
So the first word you will find is 3-letter word, which will be cat, and then you just divide that, and then go in that direction ahead. by moving the index on to the S, right?
Yeah.
And then you actually again do the same thing for the SANDDOG until you don't find two of those words, right?
Yeah.
And that's what I believe that what Leon is suggesting will actually take care of that part to finding
Correct.
that.
Yeah.
that.
Got it. All right. I'll hand it over to whoever was showing up.
Sure, yeah.
Thanks, guys.
Yeah, thank you. Yeah, so what he was saying here is 3 is a cat and dog, and then we have another for 4, yeah.
Four will have cats and sand.
Cats and sand.
Cats and sand.
And now when we will actually find the substring, so we just need to check that if do we have a length 1 substring or not.
No.
So you started reading through the cats and dog, the whole S string, and then for the first one, there is no matching. Then you go for second, nothing. Until you come to
you will just look for the length.
Yeah.
Yeah.
So when you come to 3, then you go to that third bucket, and you compare those that word with any of the words over there.
Or we can use a set here instead of list. So that,
Yeah.
To improve.
Yeah, that also makes sense. Yeah.
So you're saying you want a map which is integer and then a set that
Yes.
gets the
Right.
length? Okay. And why is it better than just having a set? And with these words.
Then you will
Because
have.
we know the length, the valid length.
Oh, okay.
Because you don't want to check like 1, 2, right? We can check 3 and 4 only.
Oh, okay. Got it. Thanks.
So this length can be, let's say, there are suppose m words are coming in this, corresponding to 3.
I
This
think, I
case
mean,
won't be order.
what he was suggesting that how that will actually help to or give the better, but big of an if we just use the set of these words instead of length and then the separate set. I don't think so. I mean, that will give the better. Even having a simple set should be enough.
Yeah.
Or maybe instead of set, you can use unordered map the way.
Yes, I mean that which can give us the constant time of lookup.
Right.
Yeah, I think, I mean, we don't need to have the map, just the set should be enough.
Yeah.
Okay. So anyone wants to share their screen? Leon, do you want to share? Have an implementation like that?
No, I don't.
Okay.
I used like DP. I used.
Okay.
It's the same. Yeah. So I just this is a start with will check prefix of it was like let's say you say cat, then it will pick cat. It will check whether this starts from cat or not, the entire string. So once it's found that it starts with cat, it will try to kick out this cat out of the entire string. Now you are left only with sand, dog. Next it will check cats, no, and it will check sand. Sand is there again. Sand it will take and then remove it out, and then again it will check with dog. So it will remove this, and I'm checking this. Once the length is equal, we are appending it. And this is just the format of printing, like what they have said, string of list, a list of strings. So I'm putting the item, and before recursing anything, if I'll check whether if it's already present in the memo table, we don't need to recurse this, simply return from there. Else, or if you recurse them, then put it in the this memo table, so that next time we don't need to compute it again.
Does that look like dynamic programming?
Yeah,
You need to
yeah,
memo.
DP only.
Yeah.
It's a DP only.
So how do you do the backtracking here? How do you come back?
Here, no, in this one, I'm using this DP I'm using here. For that, I
Correct.
haven't implemented backtracking. Yeah. But if you
So,
want to use backtracking, say, continue.
sorry. Yeah, please continue.
No, I complete. You wanted to say something like.
Okay, so no, so what I was thinking was you said you were explaining cat and dogs, cat, sand, and dog. Now, how does it go back all the way and do cats and dog?
Let's like I took first time cat. Okay. Cat
Okay.
got removed
Because
from here. Then
he is going through each and every string length, right?
words in the list.
So once he does that cat, then he starts from sand dog for the helper function, which goes in the DFS mode, right? And then when he comes back, then he starts with the letter cats, CATS, and then he again goes for the helper word with ANDDOG in a DFS way. Right? Is that correct?
Yeah,
Yeah, look like.
Yeah.
So therefore,
But the runtime complexity. So you need to.
This for loop only it's running. For within this one item order of n square it will be. And that also occasionally it's running. If, yes.
But we need to include the size of the dictionary, right?
That's the space, right? This your size of dictionary.
Is it only ON square? I don't think, right? Because
it should be, I mean,
size of recursion tree will go something more, right?
I think maybe.
What is n? N is the size of the string.
Size of the string,
yeah. Size of the string.
But this one we look through all the word in the dictionary. So somehow we have to include it. For each iteration, right? Like initially you look at the cat, right? The next iteration, you look at cats and need to go through that again.
Yeah, I think we should look for the worst case, like when the worst case will happen. I think assume that none of the word exists, right? So we are actually checking C, then CA, then CAT, then CATS, then CATSA, then CATSN, right?
Yeah.
So if we take that also takes over n square.
But I was thinking it might be slightly more than that.
Yep, that's true.
Yeah, it might be ON cube maybe. So because we are iterating through in a DFS manner, right? Again and again, if you go in that.
Why it will take n square, I'm not able to understand that part.
See,
so
like
we start with the first character, we check that, and assuming that the dictionary will give the constant time, right?
But
so,
then you go for the next one in that helper function in a DFS mode, right? You actually move that, and again you start from the start of the string, or maybe not the start, but wherever you left with the index. So if the index, if you just completed only 3, and if you have a million words remaining, million alphabets remaining, right? So you still have to go and iterate through the whole string again, and then you'll have another, you find another word and again go in a helper function again below that. And then you'll have to return back also every time coming up, right?
Yeah, that's it.
So it will be at least, I think, ON, more than ON square.
Yeah, that is true. So if we look in terms of complexity, right? That's if we look it in the form of a recursive formula, so it will be T of n will be in the worst case will be T of 1 plus t of 2 plus t of 3 plus t of 4 till t of n, where t is denoting the time taken for the nth string to compute, right?
Hmm.
And I think we should try to solve this tree. It should be some exponential, big exponential, I think.
So
Yeah,
at
it will
every
be
node, I
exponential
would,
if you are not using memoization, right?
Like
If you
memoization,
use-
okay, memoization will only help if there is some sub problem,
Yeah.
right? In the worst case, assume memoization is not happening.
Right.
So that's what I was saying. Like you have to look at the worst case. You're looking at the big one, not the small one, right?
Correct.
yeah.
So that's why.
So at every level, the node will be split into two parts only, no? Or
No. Why two?
we'll see.
Why
Yeah,
two?
definitely it can go
So-
further.
So
Depends
that's why
on the
I'm
length of
saying,
sentence.
yeah. So that's why let's assume the dictionary contains C, CA,
See.
CAT, CATS,
Hmm.
CATSA, CATSN. Assume that all these things are there, right? So
Okay.
your recursion formula will become T of n equal to T of 1 plus T of 2 plus T of 3 plus T of 4 plus T of 5 and so forth and so on, right?
Huh?
And every
Okay.
individual in this is also a tree,
Right.
right?
Shouldn't we start first of T of n, which is the length of the string, and then T of n minus 1?
Yes, so
T of
that's
n
what
minus
I'm
2.
saying.
So
And then
also actually, if because you might hit a TLE in that case, right? There is one test case actually, which goes
AAA.
that long. Yeah. So for that, what you need to do is you need to actually look whether it is really feasible also. If it is feasible, then only you go and do all this stuff. So that is two way of doing it. First, you have to find out whether you're really going to get any sentence out of it. If you're not going to get any sentence, you don't even have to go and do all these things. Get all the, because actually looking at a dictionary and then parsing all that thing, it takes more processing time. And therefore you hit a TLE on that particular test case. So you need to actually have that check. At least for the bottom-up approach, that is the way you have to do. But this the top-down approach works without even doing the check.
That AA is taken care by this memoization, I think. Otherwise,
yeah, but bottom-up approach also actually does sort of storage of all the results, right?
yeah.
But you still hit a TLE in that case, and if you don't have that particular condition, you are not able to encounter or maybe that overcome the TLE.
Do you have a code for bottom up? Like if you want to share, like
Yeah, I have one.
Okay, share it. I'll stop.
Yeah, so I was talking about this test case actually.
Yeah.
Maybe I'll come to that later. Okay, let me. Yeah, so this is the bottom approach. And in this bottom-up approach, using this vector string, this is C++ implementation. So this is the entry function. And then I'm using an unordered set to convert this dictionary of a string array into an unordered set. And here is the condition actually I check for the test case 31, which is of A's. And if I'm not able to find any valid solution, just return it from here. Or else this is the bottom-up approach. So this is a DP array of n is actually length of the string, so n plus 1. So in the first location, I just push back an empty list, and therefore I have some value over there. And I need that actually for comparison. If there is something in a previous element, then only you can go and add that word. So I'm just running through the string in this case. with this first for loop, the ith index. And in the second index, actually I'm iterating through from 0th position of that index to the length of this S string, and then actually look for this in this DP, what the previous one, if it has some value. If it has some value, it means there is some word in it, so I can continue ahead. And then this is the WD, which is the dictionary, which I look for a substring, which I just found out from this one. If I find any of them is valid, then go inside that and then push in that list, because I'm always maintaining a list of all the strings in this particular, each and every element of this DP array. Okay, so I just keep on pushing over here, and if I get all that at the end, so I'll have the complete sentences or the vector of strings in this last element value of the DP. So this is a very simple implementation, but I was actually not, I was getting a TLE on that AAA case, and the AAA is like, sorry, not AAA, it is AAA. I'll just share my notepad here.
So that the bottom up looks like n cube, right? Like
yeah, it will be, it will be n cube. So this is a special test case. Actually, it hits a TLE in that, because you see there are many AA everywhere. So whenever you want to compare anything for any string, you have to go through the whole list, so whole list of all these AAs. My notepad is visible, right?
Yeah.
So the trick what has been done, because I also got from the other solutions. So what they do is actually go through this string first, and then for each and every element, for each and every length of the string, just look whether there is a viable solution. And why we can't do it, like if I consider something like the first 3 A's or 4 A's, so I keep on looking for each of one of them. So in this case, it will be 4 times I'm looking here. Then I'm spending more time. If it is a bigger string or all A's, so I'll be computing for all of that for a particular location. And then I keep doing that, like maybe if it is, in this case, there are 20. So for just at this location, I go for looking for 20 times. Then if I go for the string is about 1,000 times. So 20 into 1,000, 20,000 times I keep on doing it. And at the end, I say, okay, it's not going to work. So then it TLEs. So therefore, the trick what they say is, just do this word break here. It is similar approach of the bottom up, again the same thing, but just do a lightweight, like you have a vector ball here, and then go through the string length again, and every time do the same thing for a jth index whenever you have a string of a particular length, and for each and every length actually starts from 1 to n. And in that, just find out if there is a substring, valid substring, which is possible for that location. If it is there, just mark that as a true based on the previous length of the previous string, and then they break out. If you don't break out, you will actually end up doing each and every string, and therefore actually it TLEs, because the bottom-up approach and verifying whether the word break is really possible or not approach, they both are same, but only difference is I'm breaking over here, so I'm not going for each and every combination. So that reduces a lot of time, and also the processing and creating of the strings, that also is avoided. And so just find out if it is not possible, then just break it from here. And therefore this A actually is false. It is not true, because you can't make anything there, and therefore you return from here for A, and for the rest of the things actually it works.
What would be the example of non-viable?
I'm sorry. Yeah, sorry.
Yeah, when you go back.
Yes.
Could you go back to the previous one, or can you give an example of you say if it's non-viable solution, then you break it out?
Yeah, so this
Can
one I
you
was
give an
talking about, you
example?
know.
Yeah.
So if you have that A, okay. So if you have this big A, your string, and if you have these AAs over here. So, you know, like if for this bottoms up approach, what we do is we go for each and every length of a string. Like first we start with the first A, you know, and then you go for the second A like this, right? Third A. So every time you actually iterate through this list every time, right? So whether you, and this is the way it does it, whenever you go through each and every end, you try to find out for each and every element of the second array, and that is a word dictionary, right? And then you actually go and add that in this DP array, correct?
Right.
So
Yeah.
that involves a lot of processing because all the words are, all the alphabets are same. And if you have this list also, the word dictionary also bigger one, and incrementing count, so you end up doing a lot of processing for each and every element of that string. And
So
that
bottom, so in bottom up also you are generating all substrings only, right? Only advantage is you are taking care of that memoization is helping you to avoid from TLE, right? Like we'll start from
so yeah, bottom up approach and top down approach, actually there's not much of a difference though.
Yeah.
Usually it is like that, you know, but the way it is implemented, it's implemented in an iterative way instead of a recursive way. Correct.
Oh, okay.
So that is the only difference. But for this particular problem, the test case 31, I was also getting a TLE always, because usually you don't get a TLE in a bottoms up approach. But for this problem, you get.
Yeah.
And why I was getting it, I was just trying to find out, and this was the test case. It was all A's, and you are having like the dictionary of A, and all those things, and incremental order. So for each and every location, if you go, for each and every element of a string, you need to process through each and every string. And this is also big one, right? So for everyone, if you do it, you end up a lot of processing time.
Right.
Yeah.
So for that, you actually do this trick here. This is a word break. You just find out, I've written the same function over here. It is again a bottoms up approach also, the same thing. Go through the string again, okay? And then you actually, the way it is divided in different string lengths, you look for this one, the same way for the bottom up approach, what we did. And for each and every location, okay, you try to find out if it is possible for that to find a viable solution. If it is, then you just break here. You don't count for the other strings, you know, these other strings, like the other dictionary words. So once you find for one of them, that is enough. But for the real one, you have to do. But why you have to do this? If you find a viable solution, okay, then at the end you will have a true value. So in that case, you go ahead, or else you just terminate from here. And this test case actually returns a false value. But we end up doing a lot of processing, and therefore we hit a TLE.
TLE.
So that is the only difference for this bottom up approach here. And therefore I was getting a TLE. Many people were also getting a TLE there. And this is the only hack over there. But it works for the top-down approach without doing all this trick.
No, but what about even if in top-down, instead of actually looking for the smallest substring, we start with the biggest one and then reduce the substring from there?
So you are saying for the top-down approach?
What you are
Yeah, this is what we do in.
Can you repeat what you just said?
What I'm saying that, I mean, instead of actually looking for the smallest substring first, so if we look for the biggest substring and then reduce the substring.
Well, then that will become top down, man. Like for the bottom sub, you basically start from the smallest thing.
But either way you do it, it should end up with the same results.
Yeah, I'm talking about in terms of algorithmic definitions, right?
Okay.
Bottoms is basically you start with the length 0, then length 1, length 2, length 3, and so forth, right? So you basically building the tree from the bottom, but in the top down, you're building the tree from the top.
Yeah, but actually, if you you go in the tree, start with a
It's up to us. How do we define the bottom?
No, it's not.
So you're saying that it's always the smallest one?
That's what, like in like, I'm not saying how you implement the top down. It's not like the top down has always been memorization. No, it depends on you, but the bottoms up is always the minimum. Like you basically take the sub problem and grow it, right? Whereas in case of top down, you take the entire problem and then shrink it. That's all. That's the difference between top down and bottoms up.
But you need to, even if the top down, you need to shrink it by how much, right? If you shrink it by one character at a time, then it's the same as the bottom up.
Yeah, it depends on problem to problem. That is, but in this case, actually,
the same answer, right? So I'm not saying the answer will be different.
Yeah. But in this case, he's saying it's a different way. Yeah, that is. Yeah.
Like maybe you can have a loop solution for the top down. That's what I think he's trying to say.
Yeah. Yeah, so the top-down approach I implemented here, and I don't have to look for that particular hack what I did for the bottoms-up approach, and this works. I think Shashank also did the same in Python.
Yeah,
it's nothing different though. So why it might be working, because we are having an array of vector string there, and here it is just like making a string, using a string and adding to that, no, but not using an array of a vector string, like a multi-dimensional array of a string. Yeah. That might be only reason, I think. Other than that, the implementation looks almost the same.
Similar, yeah.
But surprisingly, I also was never, anticipating to get a TLE there, because usually I was also of the opinion that the bottoms up approach goes very smooth without any issues. But I got a TLE there. That was surprising.
Because bottom up came only to avoid TL in the top down.
Right.
Because we may run out of.
I was thinking of, that was my earlier perception, but this is not the case in this particular problem.
Yeah.
Okay.
Yeah.
I'll just stop the sharing.
Have anyone tried solving with try data structure?
Try actually, yeah, I did. Maybe let me check if I have that solution over here. No, I don't have it here now. But actually, for try, you need to actually go and yeah, sorry, someone was talking.
I mean, I think with try it should be straightforward.
Right. So if you look in the description section, I can quickly show you one try which I was looking for. And I think, yeah, this one they were talking about. Yeah. So like what he does here in this try, this is a try node. He creates the try node, okay, and then you create a try class.
You're not sharing your screen.
Screen is not screen.
Oh, sorry.
Okay.
I do that many times. Oh, is it visible?
Yeah.
Yeah. So in this, this is a class actually for this try node, okay, where there is one flag, and then it has an array of pointers of the try node, which is 26 for the alphabets. And then there is this class, right, the try class. And in the try class, you have an insert function which inserts a word. And then you have a search function, member function, and the starts with function, right? So the way it is implemented for our problem using this try class, you go in this word break, and first actually use a try to actually the word dictionary actually is converted and inserted in the try. That's the only thing it does. Once you're, instead of using an unordered what do you say, a dictionary and all that, we are using a try. And then every time you go through the try, you start with the try root, okay, and then use that, and then keep on crawling for each and every element of finding each and every alphabet. And if you don't find it, just break it over here, okay, and or else if you find it, then do the regular DFS. So this is the DFS here, and then it comes over here, and then again from the try root, it keeps on looking for each and every word, and if it finds out, okay, and then it just adds over here and sends to the DFS, so it can actually create that particular vector string in the results for vector of results. Or else they use I think the backtracking also over here.
It's backtracking only, I think,
Yeah.
with the help of,
So then it works. Yeah, I didn't
That's what
implement though,
DFS
but it was, I thought maybe
Yeah.
easier way to understand.
So try will reduce the space of it. I mean, what extra advantage you are getting out of try instead of dictionary? I mean, unordered map.
Try actually condenses the whole dictionary, so retrieving any word from that is very quick.
The same in dictionary also, order of one it will take to get anything.
But
in
what
hash map.
happens in the dictionary, you have to go and look for a word. Here what happens, each and every prefix, when you are actually formulating, at that time immediately it will give you the results.
Oh. Mhm.
It's like the
Yeah.
autocomplete feature, what they say, if you keep on typing, then it shows the list of words over there, and that is what the try
Mhm.
implementation is. So it is very quick, because whenever you are putting another alphabet, the try moves to the next node in that try tree, and then it can even give all the list, because the list, you can store the list of words which have the same prefix there too. Means you can do it a different way, different type of implementations, and therefore it is much faster.
Does the time complexity increases, like the better gets better?
Time complexity in the sense
O of n, or like right now we said n cube, right, with the top down.
I think at least it will go for n square. It's not going to be
Order of n.
it won't be of order of n, because you are actually going in a DFS mode again, right? So keep on accessing that. I'm not sure though, but yeah. But constructing the try is again a big thing, because if the number of words are huge, then it will take more time in constructing the try.
Okay.
So this Google autocomplete feature uses try, right?
Yeah, that is what they say.
Oh, okay.
There are many applications of try.
Yeah.
We implement it in a very efficient way. It is very useful.
No.
Okay,
Yeah.
I'll stop
Yeah.
sharing.
No. It's over on that.
Stop recording.
So